Hello student, how are you all and how your study is going on? Hoping for your best. So I'm today here with this new topic that it is regarding to the capacitor. So here it is, effect of dielectric on capacitance. So student, if we are going to place a dielectric medium between the plates of capacitor, so what will be the effect of this on its capacitance, or either we can also going to call this as capacitance of parallel plate capacitor with dielectric medium between the two plate. Okay, so this dielectric constant, student, dielectric that already we have discussed in our previous that videos, but let us to look over here once again what is said in that video, student. There we said that if I have this one, it is a dielectric that substance. Dielectric means insulator. Okay, so when it is placed in the electric field, so there it is electric field toward right. Okay, so this electric field it is exterior electric field. Okay, so when it is placed in exterior electric field, so what happens that these charges get induced on its surface. There it is negative charge and positive charge that will feel the repulsion of the electric field, then they will be on the farther face. So we are looking over here, there is the separation of positive and negative, so a field will set toward the left. Okay, so this was the field that we called it is the field due to polarization there in that video, student. So this is that field which is inside due to of these charges which get accumulate on its surface. But we have also seen over there this internal field, it was not exactly equal to external. Okay, it was small electric field because these were few charges which comes on the surface, as this insulator do not have that free charges. That's why this internal the field which is inside, it will be smaller. Okay, so then what will be the net field? So there we said that this net field, it will be because external field is greater than that of internal field, so we get that this is net field, or either we call this is as reduced field. Okay, so what this dielectric has done, so this has reduced the electric field inside it. Okay, so this field is equal to E. Okay, so over there, by what factor this field has reduced? So we can calculate that with the help of dielectric constant. So we said over there that external field, it was E naught, and in that reduced field inside this it become E. So the ratio of this will give us that constant value by which this field get reduced. Okay, so this K thereafter we call it is as dielectric constant. Okay, so this we have done in our previous videos, student, which is regarding to the dielectric medium. Now over here, let us to start it with this parallel plate capacitor. I'm supposing over here, student, here is this parallel plate capacitor. So this is its plate number 1. Here is this plate number 2. So they will have equal and opposite charge. So one it is having plus Q, another will have minus of Q. Both will have same cross section area, and one will have this surface charge density sigma, while the other will have its surface charge density minus of sigma. Okay, so there it is positive charge on its surface, and while it will have negative charge over here. So there is electric field in that region which is between the two parallel plate, and this field it is from left to right side. Okay, so this is that field which is between the plate, and we called it is as E naught. Okay, so right now, student, we are supposing that inside the plate there is vacuum. Okay, so we have already done that this capacitance, what it will be in this case, capacitance of capacitor with no medium inside plate. Okay, so this already student we have calculate what was this, let it be C naught. This capacitance we called it as C naught, and it was epsilon naught AY. That separation between the two plate, it is small d, so it is d over here. And how much was this electric field between the two plate? It was sigma y epsilon naught. This was over there. Sigma, it was what? Surface charge density. Okay, so their surface charge density, it was charge on its unit area. So we can also write it as, why we have written it in this way, because we were knowing that surface charge density, it is what? Charge on its unit area. That's why this electric field, we get that its formula over here, that it is q by a epsilon naught. Okay, this is that electric field between the two oppositely charged plate. Okay, now let us to do one thing, student. What we have to do? We have to place a dielectric medium now. Okay, so for this, in the same I have to place the dielectric, but for this I am making a separate diagram. Okay, so this I am taking over here, it is one of the plate, here it is the another plate. So one plate it is positively charged while the other plate is negatively charged. Separation between them, it is d, it is having positive charge. All things are same as which is written previously. So it is having minus q charge, area of cross section A, minus sigma is there, it is having q charge, area of cross section A, and surface charge density sigma. Now student, over here this electric field, it is which is outside, which is between the plate, it is E naught. Okay, now over here inside this field I am going to place a dielectric medium. Here I am going to place this dielectric medium. Okay, so out of which I have told you earlier. Okay, now the thickness of this I am going to suppose it is to be T. It is the T thickness of this dielectric substance. So therefore the capacitance of parallel plate capacitor with a dielectric medium between two plates, so for the case T is less than D. Okay, what we are going to do over there? We are taking this case that the thickness is smaller as compared to that separation between the plate. Okay, now over here student, as we are known that when this dielectric is placed in this electric field, E naught is that electric field in which it is placed. So what will happen? Negative charge will be induced on this surface and positive charge that will move on this surface. Okay, so what will be the field inside? So inside this field, as already said over here, this inside field, it will be reduced field. So it will be E. Directly I am going to write over here. Okay, so that reduced field inside this one, it is E. So just to look over here, E is that field which is inside the boundary of the insulating medium, and outside of this insulating medium there is E naught. Okay, so then we are having over there two field. One field, it is E naught, which is outside the medium, dielectric medium, while this E is inside the dielectric medium. Okay, so therefore student, how much is the potential difference between the two plate? So potential difference between the two plates, so we are having plate number 1 and plate number 2. Okay, so just to look over here, this potential difference, let it be V. Now you will find over there there is E naught field, E naught electric field. It is in which region? It is just outside the dielectric medium. Okay, so total separation, it was D, and the thickness of this dielectric, it is T. So how much is the space which left outside dielectric? It is D minus T. This is the space D minus T which is outside dielectric, and in this region there is E naught field, plus that E electric field is there in which region? Only in T thickness. Inside the dielectric medium there is only reduced electric field, E. Okay, so thus I have over here student, just to look in this formula which is of dielectric constant, reduced field, what it will be? It will be E naught by K. So put it over here in this formula. It is E naught d minus t plus of E naught y k, and it is t. Okay, and that is potential difference. So what thing is common? E naught we can take it out common, and it is d minus t plus ty k. Okay, this is that potential difference. Now we can do the thing that we can put the value of this E naught. Okay, so which can further be that that implies V is equal to this E naught. It is q y a epsilon naught, already written over here just to check it, and it is d minus t plus ty k. So therefore what will be this capacitance now? Okay, so we have to use the formula only of the this capacitance. So therefore capacitance, so student, let its capacitance is C, and that is what? The charge required to raise its potential difference by unity. Okay, so Q is there as it is. V we have just calculated, it is Q by A epsilon naught d minus t plus ty k. Okay, this is over here. So Q and Q is going to cancel, and I have, and this will go in the numerator A epsilon naught, and the thing that will remain under d minus t plus ty k. Okay, so it is that capacitance of this capacitor with a dielectric medium. Okay, this is that formula which you can use over there. Now student, just to suppose that special case which I am taking over here, special case. So if this whole space is occupied by this dielectric medium, so what will happen? Okay, so that full separation between the two plate, it is equal to that the thickness of this dielectric medium. Okay, so what will happen to its capacitance, student? So we are looking that this will become A epsilon naught d minus this t will be equal to d, so it is d plus dy k. Okay, so this is going to cancel, and finally I am having it is A epsilon naught by d, and this k will come to that numerator. Okay, now I have this one, it is k A epsilon naught by d. But now check over there, student, what is that already we have written. Just to check that where we started, when we started, so that time we said that when there is no medium, so at that time its capacitance is C naught, when there is no medium. Okay, so C naught, it was epsilon naught A by D. Okay, so just to check over here, A epsilon naught by D, so what we called it earlier, it is C naught. So therefore this capacitance, then I can have it is C is equal to K C naught. Okay, this is that capacitance of this capacitor. It is what? Capacitance with dielectric medium. Dielectric medium. And this was what? Capacitance without medium. Without medium. So we are looking over here that this capacitance get increased if we are going to fill it with that dielectric medium. So it increases by k time, as much will be there that dielectric constant of that. Now student, this dielectric constant we can also write it over here. The formula that we are getting, it is C by C naught. This is what? Capacitance of medium. It is capacitance of medium, and that of C naught, it is capacitance of vacuum. Okay, it is what? Capacitance of vacuum. So this is what? This is dielectric constant. So over here, student, we are looking that we are getting another formula for dielectric constant as well. As already we have written, dielectric constant is what? That it is field in that external to this reduced field. It is already said to us what is that? Dielectric constant. And previously we have done already that it is the ratio of permittivity of that medium to this permittivity of free space, that was also dielectric constant. And before of this we have written this one as it is the ratio of that force in the vacuum to that force in that medium. Okay, so therefore that in the different way you are going to define this dielectric constant. Okay, so all that things are dielectrics. Okay, so this is all from my today's video. Thank you for watching.